Sheila is investigating the number of grey square tiles needed to make patterns in a sequence. The first 3 patterns are shown below. First pattern, second pattern, third pattern. And the sequence continues in the same way. In each pattern, the tiles form a square and its 2 diagonals. So here's the square, there's the diagonals. There are no tiles in the white areas in the patterns. There are only grey tiles. Part A. In the table below, write the number of tiles needed for each of the first 5 patterns. B. Find in terms of n a formula that gives the number of tiles needed to make the nth pattern. C. Using your formula or otherwise, find the number of tiles in the 10th pattern. D. Sheila has 399 tiles. What is the biggest pattern in the sequence that she can make? Sheila starts at the beginning of the sequence and makes as many of the patterns as she can. She does not break up the earlier patterns to make new ones. For example, after making the first 2 patterns, she has used up 54 tiles, 21 plus 33. How many patterns can she make in total with her 399 tiles? Well, I'm going to start by drawing out the 4th and 5th pattern. So if we have a look in pattern 1, we had 5 squares across and 5 squares down. In pattern 2, we had 7 squares across and 7 squares down. In pattern 3, we have 9 squares across and 9 squares down. So in the next pattern, we're going to have 11 squares across, 11 squares down. And then the 5th pattern, we're going to have 13 squares across and 13 squares down. And then we're going to draw in each of the diagonals. So if we add up all the tiles, we have 21 in the first pattern, 33 in the second pattern, 45 in the next pattern, 57 in the 4th pattern, and 69 in the 5th pattern. So part A, in the table below, write the number of tiles needed for each of the first 5 patterns. So we just need to fill in these 3 boxes here. So we end up getting 21, 33, 45, 57, and 69. So we're going to use these numbers in the next question. Part B, find in terms of n a formula that gives the number of tiles needed to make the nth pattern. So what we have to do is find the difference between each term. And to get from 21 to 33, it's plus 12. From 33 to 45, it's plus 12. 45 to 57, it's plus 12. 57 to 69, it's plus 12. So we have the same first difference. So we know that this sequence is linear or arithmetic. So we're going to use our 0 term method. And what we do is we take our first difference, which is 12. We stick an n on. And then we go back by 12 to find the 0 term. So if 21 was the first term, going back by 12 will get us to term 0. And 21 take away 12 is 9. So we get 12n plus 9 for our nth term. Alternatively, you could use the formula in the formula book. Part C, using your formula or otherwise, find the number of tiles in the 10th pattern. So what we do is we take our nth term that we got in the last question, which is 12n plus 9, and we swap the n for 10 with brackets around it. To find the 10th term, we swap the n for 10 with brackets around it. 20 times 10 is 120, plus 9 is 129. So the 10th pattern will have 129 grey tiles. Sheila has 399 tiles. What is the biggest pattern in the sequence that she can make? So again, we're going to use our nth term formula for this, which is 12n plus 9. And we're going to equal it to 399 because we're told that she has 399 tiles. Then we're going to solve for n. We're going to get rid of that plus 9 by minusing 9 to both sides, so that cancels out. Then we have 12n equals 399 minus 9, which is 390. Then we divide by 12 on both sides to get rid of that 12. And we get n equals 390 divided by 12, which is 32.5. So the biggest pattern is going to be the 32nd pattern, because the 0.5 means that we will have some tiles left over, but we will have 32 full patterns. Find, in terms of n, a formula for the total number of tiles in the first n pattern. So the total number of tiles in the first n pattern, that means the sum of tiles. So we're going to use our sum of series formula. And we get this on page 22 of our formula tables. So our formula is Sn equals n over 2 multiplied by 2a plus n minus 1 times d. So we need to figure out what the a is and what the d is. So the a represents the first term. So the first term is 21, so a is equal to 21. And the d represents the common difference. So 12 is going to be the common difference. So we swap the a for 21 with brackets around it and the d for 12 with brackets around it. We do not know what the n is because we want a formula in terms of n. We want n in our formula. So we have n over 2, which becomes a half n. 2 by 21 is 42. N multiplied by 12 is 12n. Minus 1 multiplied by 12 is minus 12. 42 minus 12 is 30. A half of 30 is 15. A half of 12 is 6. N times 15 is 15n. N times 6n is 6n squared. So our formula is going to be 15n plus 6n squared. That's our Sn formula, our sum of series formula. So we can substitute into this formula to find the total number of tiles in any number of patterns. Sheila starts at the beginning of the sequence and makes up as many of the patterns as she can. She does not break up the earlier patterns to make new ones. For example, after making the first two patterns, she has used 54 tiles. That's 21 plus 33, the first two terms added together. How many patterns can she make in total with her 399 tiles? So we're going to take our sum of series formula that we created in the last question, and we're going to let it equal to 399 because she has 399 tiles. So swap the Sn for 399, and that's equal to 15n plus 6n squared. If we bring everything over the same side and keeping our n squared as positive, the 399 comes over and becomes minus 399. So you get 6n squared plus 15n minus 399 is equal to 0. We can divide across by 3. So 6 divided by 3 is 2, 15 divided by 3 is 5, minus 399 divided by 3 is minus 133. And then we're going to solve for n. So we label our first term as a, our second term as b, and our third term as c. And we use our quadratic formula that we get from our formula tables. We swap the b for 5 with brackets around it, and in here as well with brackets around it. We swap the a for 2 with brackets around it, and we swap the c for minus 133 with brackets around it. Then we swap that a for 2 with brackets around it as well. The brackets are really important because if this happened to be a negative and there was no brackets involved, we would square it and then stick on the minus sign and it would be incorrect. So we have to use brackets all the time. So minus 5 we bring down here, the plus and the minus. 5 squared minus 4 by 2 multiplied by minus 133 gives us 1089. 2 by 2 is 4. So now we want to break this up into two sums, one with a plus and one with a minus. So here we're using the plus and here we're using the minus. And minus 5 plus root 1089 over 4 gives us 7. And minus 5 minus root 1089 over 4 gives us minus 9.5. The answer must be positive, so 7 patterns can be made with 399 tiles. Because you wouldn't say you've got minus 9 patterns or minus 9.5 patterns. That doesn't make sense. So there must be 7 patterns that can be made with 399 tiles.